All right, hello everyone. Our lecture today is going to be on section 6.7, solving quadratic equations using the zero factor property. So this is our last lecture here of the semester. So let's make it a good one. All right, we got two objectives. So first objective is we want to solve quadratic equations using the zero factor property. And then objective 2, we want to solve other equations using the zero factor property. So this entire lecture is really just on the zero factor property and how we use it with quadratic equations and also different types of equations. So a quadratic equation in X can be written in the form of ax squared plus bx plus c is equal to 0. It's really just a trinomial, but we call it the quadratic equation. So a, b, and c are real numbers and a does not equal 0. This given form is called standard form. So examples would be x squared plus 5x plus 6 is equal to 0, or 2x squared minus 5x is equal to 3, or x squared is equal to 4. So it's really just trinomials that we're setting equal to 0 and or setting equal to a number, which we will then set equal to 0. So objective 1, we want to solve quadratic equations using the zero factor property. So we can use the following property to solve some quadratic equations. The zero factor property states that if a and b are real numbers and a times b is equal to 0, then a is equal to 0 or b is equal to 0. In words, if the product of two numbers is 0, then at least one of the numbers must be 0. One number must be 0, but both may be 0. So once again, one of them has to be 0, but they can also both be 0, but one of them has to be 0. So we're really just going to use this property to try and find solutions of the quadratic equation. So let's show how we do this. So first things first, we want to set up our quadratic equation. And our quadratic equation is equal to 0. And x squared minus 5x is equal to negative 6 is not equal to 0. So let's go ahead and add 6 to both sides to get our quadratic equation. So we'll add 6 to both sides to get our quadratic equation. So we'll get x squared minus 5x plus 6 is equal to negative 6 plus 6, which just gives us x squared minus 5x plus 6 is equal to 0. Now let's focus on the trinomial part of this equation. So we're going to focus on x squared minus 5x plus 6. And we just had multiple sections on factoring. So let's factor this trinomial. We have x squared minus 5x plus 6. We want our factors to be product, or we want our factors when they're multiplied have the product of 6. So we're looking for two factors of 6 whose sum is going to be negative 5. Since we have positive 6 and negative 5, this means that both terms will be negative. And the only terms that would make this make sense would be negative 2 and negative 3. So these factors, which let's put this in blue, these factors are going to be negative 2 and negative 3. So if we write our trinomial, which we said we can always express in factored form, we're going to express our trinomial in factored form to get x minus 2 times x minus 3, which we're now setting equal to 0. So we set the factored form of the trinomial equal to 0. And now we're going to use our zero factor property because we want to find our solution, or in this case, it's going to be our solution set. So our zero factor property told us that if A and B are real numbers or real expressions, then A times B is equal to 0, or if A times B is equal to 0, then A equals 0 or B is equal to 0. So this is essentially like saying that x minus 2 is equal to A, and x minus 3 is equal to B. So here we're really saying that A times B is equal to 0, which is our zero factor property. This also means that A has to be equal to 0 or B has to be equal to 0. Or they can both be equal to 0, but one has to be true. So we'll say A equal to 0 and B equal to 0, which really simplifies to x minus 2 equal to 0. And x minus 3 is equal to 0. So now we can solve them separately. We said that x minus 2 is equal to 0. All we do is add 2 to both sides to get a solution of x. This gives us x is equal to 2. And same thing for x minus 3. We add 3 to both sides, and this gives us x is equal to 3. These are both solutions of our quadratic equation. Our instructions were to solve the equation. We want to solve for this problem. But since we could factor out our trinomial into two binomials, this means that we have two possible solutions. Our possible solutions are positive 2 and positive 3. This means that instead of one solution, you will have a solution set. And the solution set is 2 and 3. So these would be the answers to our problem. And this is when we use our zero factor property, we're saying that one of these binomials has to be equal to 0 for this equation to be equal to 0. They can both be 0. That means that our solution can be 2 and 3, or just 2 or just 3. That's why we write our solution set. If you just want to check to make sure that this is correct, you just need to plug in 2, 3, or both to make sure. So let's plug in 2. So we had x squared minus 5x plus 6 is equal to 0. So this would be 2 squared minus 5 times 2 plus 6. And we're just checking to make sure that this is equal to 0. 2 squared is going to be 4. 5 times 2 is 10, plus 6 is equal to 0. 4 minus 10 is negative 6, plus 6 is equal to 0. So this is correct. 2 is a solution. So now we can try 3. So in this case, we'll have 3 squared minus 5 times 3 plus 6, which we say is equal to 0. 3 squared is 9 minus 15 plus 6 is equal to 0. 9 minus 15 is negative 6 plus 6 is equal to 0. So this is correct as well. So we see that our solutions 2 and 3 would both make this equation true. So to summarize, solving a quadratic equation using the zero factor property. Step one, you want to write the equation in standard form. That is with all terms on one side of the equality symbol and descending powers of the variable and zero on the other side. So that's what we did here. We rewrote into our standard form. So here, this was step one. Step two, we factored completely. So this was step two. Step three, we applied the zero factor property, which was about here, step three. Step four, solve the resulting equations, which was the step here. And step five, we just want to check. So this was step five. But so our steps being write the equation in standard form. Step two, we want to factor complete, we want to factor that trinomial. Step three, apply the zero factor property. So set each factor with a variable equal to zero. So you're setting each of those binomials equal to zero. Step four, solve the resulting equations. You have both these binomials set equal to zero and you just solve for your variable, most of the time being x, but not necessarily. And step five, just check each value in the original equation and write your solution set. So let's go ahead and do another problem. So equation two, or example two, we want to solve the equation. We have 4p squared plus 40 is equal to 26p. So step one, we write this in standard form. So to get this in standard form, we need to subtract 26p from both sides. Once we do that, we get 4p squared minus 26p plus 40 is equal to 0. So now we have our standard form of our quadratic equation. And now we see we have a greatest common factor. The greatest common factor is going to be 2. So let's go ahead and factor out 2. We want our quadratic equation to be in its simplest form. So this will give us 2 times 2p squared minus 13p plus 20 is equal to 0. And now step 2, we want to factor. We need to factor, so we need to find 2 negative factors. Since our last term is positive and our middle term is negative, we need to find 2 negative factors of, remember, 2 times 20, the coefficient of our first term, times our last term, not the greatest common factor. So we need to find 2 negative factors of 2 times 20, which is 40, that add to negative 13. And these numbers are going to be negative 8 and negative 5. So for this trinomial, we're going to go ahead and do factor by grouping. We have a coefficient in front of our first term, so it's a little bit easier to do it this way. So we'll rewrite, we'll have 2 times 2p squared minus 8p minus 5p plus 20. So grouping together, we can group our first 2 terms and our last 2 terms. This gives us 2p squared minus 8p. And we'll go ahead and we're going to say minus 5p minus 20. Because if we factor this negative in, we get a negative 5 plus 20. And now we can factor out our greatest common factor. Our greatest common factor in 2p squared minus 8p is going to be 2p. Our greatest common factor of 5p minus 20 is going to be 5. So we'll have 2 times 2p, p minus 4, minus 5, which is really the same thing as saying plus negative 5 times p minus 4. So we have the same binomial. We've factored out some terms here. And now we can go ahead and factor by grouping. So we'll get 2 times p minus 4 times 2p minus 5. Technically, it's 2p plus negative 5, but we know that we can rewrite that. And remember that this was all equal to 0, since this was our quadratic equation. So if you had forgotten up to this point, just fill that part in. So we've factored completely. We have 2 times p minus 4 times 2p minus 5. Since we have this whole equation equal to 0, we can actually just divide each side by 2 and get rid of the 2 completely, because our zero factor property only allows us to use a and b. It doesn't allow us another coefficient or another variable. So we'll divide each side by 2. And since our other side is just 0, it's still going to just be 0. So we have p minus 4 times 2p minus 5 equal to 0. So now we have our form in our zero factor property here. So we're applying our zero factor property. We're saying that p minus 4 is going to be a, 2p minus 5 is going to be b. So a times b is equal to 0. So this means that we can have p minus 4 is equal to 0, or we can have 2p minus 5 is equal to 0. And now we just solve for p in both cases. So p minus 4 is equal to 0. We add 4 to both sides. We just get that p is equal to 4. 2p minus 5, we add 5 to both sides to get 2p is equal to 5. We divide both sides by 2. And we get that p is equal to 5 halves, or 2.5. But we found our values. So this was step 4. So we found our values of p. And to check if we were correct, we would plug in our values. Okay. Run out of room. So let's go ahead and just check, make sure this is correct. So let's plug in p equals 4 first into our original equation, or when we set it equal to 0. 4p squared minus 26p plus 40. This would be 4p squared minus 26, 4 times 4 plus 40. And we're saying that this is equal to 0. Keep working on. So, well, that's 4 squared. So we'll get 4 times 16 minus 104 plus 40, which we're saying is equal to 0. 4 times 16 is 64 minus 104. 64 minus 104 is negative 40, plus 40 is equal to 0. So p minus 4 is, or sorry, p equals 4 is definitely a solution. Now let's try p is equal to 5 halves. This one's a little tougher. So we have 4 times 5 halves squared minus 26 times 5 halves plus 40 is equal to 0. So 5 halves squared is going to be 25 over 4. So we have 4 times 25 over 4 minus 26 times 5, which is going to be 65 plus 40 is equal to 4. 4 times 25 over 4 is just 25. It's 25 minus 65 plus 40 equal to 0. This gives us negative 40 plus 40 is equal to 0, and this is correct. Just enough room. So we checked our answers. They're both correct. So our solution set is 5 halves and 4. So you always want to check and make sure that your answers are correct. Then objective 2, we want to solve other equations using the zero factor property. So we can extend the zero factor property to solve equations that involve more than 2 factors of variables. These equations will have at least one term greater than second degree. They are not quadratic equations. Quadratic equations have the highest order of 2. But instead, these are just two separate equations that we're setting equal to 0. So we're using our zero factor property in this case. But we're not solving for a quadratic equation, so it is a little different. We have 2x minus 1 times x squared minus 9x plus 20. So we can go ahead and say that 2x minus 1 is a, and x squared minus 9x plus 20 is b. So this gives us that 2x minus 1 is equal to 0, as well as x squared minus 9x plus 20 is equal to 0. Let's go ahead and solve for a. It's fairly straightforward. We add 1 to both sides. We get 2x is equal to 1. We divide by 2, and we get x is equal to 1/2. So 1/2 is one of our solutions. But now we have x squared minus 9x plus 20 is equal to 0. Well, this is a quadratic equation. So we need to do all the same steps in solving a quadratic equation with the zero factor property. We need to factor our trinomial within our quadratic equation. So we need to find numbers that multiply to 20 and add to negative 9. These numbers are both going to be negative since we have a negative middle term, but a positive last term. And these numbers are going to end up being x minus 5, x minus 4 is equal to 0. So now we'll do the same thing. We'll use our zero factor property again. So we'll say that x minus 5 is a, x minus 4 is b, which we're saying a times b is equal to 0. So a is x minus 5 is equal to 0, b is x minus 4 is equal to 0, and we can just solve. With x minus 5, we just add 5 to both sides. So we get x is equal to 5. And x equals 4, we add 4 to both sides, and we get that x is equal to 4. So now we have 3 solutions. We used our zero factor property within another zero factor property. And this is going to give us 3 solutions. Which are all contained in our solution set. And we want to check and make sure that these are correct. So we'll use our original equation of 2x minus 1 times x squared minus 9x plus 20 is equal to 0. We're not going to multiply 2x minus 1 by our trinomial in this case because it would just be way too much. But we'll end up seeing that one of these will end up being 0. So let's start with x equal to 1/2. Plugging this in, we get 2 times 1/2 minus 1 times 1/2 squared minus 9 times 1/2 plus 20 is all equal to 0. 2 times 1/2 is just going to be 1, so we have 1 minus 1. 1/2 squared is 1/4 minus 9/2 plus 20. This is really ugly, but our binomial is just going to be 0. So we have 0 times 1/4 minus 9/2 plus 20, which is just equal to 0. So we get 0 is equal to 0, and this solution is correct. Then our next value, x is equal to 5. Supposed to be in red. We'll get 2 times 5 minus 1 times 5 squared minus 9 times 5 plus 20 is equal to 0. 2 times 5 is just 10. Minus 1 is 9. So we get 9 times 5 squared is 25 minus 9 times 5, which is 45, plus 20 is equal to 0. 25 minus 45 is negative 20 plus 20, which is 9 times 0, which is going to be 0. So x equals 5 is also correct. And lastly, we want to check x equals 4. So we get 2 times 4 minus 1 times 4 squared minus 9 times 4 plus 20 is equal to 0. 2 times 4 is 8, minus 1 is 7. 4 squared is 16, minus 9 times 4 is 36. Plus 20 is equal to 0. We get 7 times 16 minus 36, which is negative 20, plus 20 is equal to 0. And we get 7 times 0 is equal to 0, which is correct. So our solution set is all of these 3 answers. So our solution set is going to be 1/2, 4, and 5. So all right, that wraps up section 6.7, which was our very last section. So this was our very last lecture. Thank you all for a great semester, and I will see you again at the final.